Okay, the first thing you need to look at is that there is a table here to help you. It says it is an insoluble salt. Name two that would make lead carbonate. To make lead carbonate, I need something with lead, something with carbonate. Lead nitrate, sodium carbonate. You then need to use this equation it tells you. It says explain what is seen. Out of these two, well, copper chloride is soluble, so you wouldn't see it. Barium sulfate is insoluble. It does not dissolve, therefore you would see it. It would form a white solid precipitate. Why? Because it is insoluble. Barium is a really good, it's really useful in medicine because it shows up on X-rays, and because it's insoluble, it doesn't dissolve in the blood. The next question, there's a few ways you could answer this. It's asking you about copper chloride. Okay? You could go the route of saying copper is a metal, chlorine is a non-metal, metal and non-metal, ionic. You could also go down the method of saying it is soluble, it can dissolve. Ionic compounds dissolve because the ions, copper and chloride, the ions can separate and dissolve in water. So it's ionic. It says it's an ionic compound. What's the most likely melting point? Ionic compounds have a high melting point because of the opposite charges and because they form a lattice structure. Highest melting point there. Finally, it says Na plus and carbonate 2 minus. So that loses 1 electron, that gains 2. And therefore, to make these charges balance, I need more positives, so I will need 2 sodium pluses to lose 2 electrons. Therefore, it will balance now if I have 2 sodiums and only 1 set of carbonate. Next question. The definition of immiscible is that it's the liquids that do not mix. Easily separated using a separating funnel by just turning the tap, running off one of them and pouring out the other. The next question tells you most of the answers. So wax has a melting point of 64 degrees. What will happen? It will melt. Why is there no visible change? You have to say why in this question. So sand, giant covalent. Sand, strong covalent bonds. Lots of energy needs to break them, therefore a high melting point. Melting points in other molecules, well, simple molecular has a low melting point, giant, we've just said high, ionic high, and most of the time metallic is high, but there are exceptions. Next question. W, X and Y are single dots. Therefore, they are not a mixture, they are just one thing, they do not separate out. Z, however, you can match across to see what it's got in it. Z clearly has a little bit of X and a little bit of Y. On your periodic table, the first columns are called groups. Group 1 are called alkali metals. The end column are called noble gases. Group 0 or group 8. Group 7 are called halogens. The middle block are called transition metals. A and B have similar reactions because they are the same group and they both have 1 outer electron. Group 1, 1 on the outer shell. Group 2, 2 on the outer shell. Mendeleev predicted this element before it was discovered. How did he know what properties it had? Well, he looked at this element here above it, this element below it, within its group. Finally, how can you use the information to calculate the number of protons in D? Well, it tells you C has got 29 protons. Here, if you take 2 steps further along this period, it will have 2 extra protons, so 29 add 2. Finally, the atomic number of an atom is 9. This is the bottom number. The mass number is 19. Describe the positions and numbers of electrons, protons and neutrons. You can look at the periodic table. By looking at these numbers, you can find it is fluorine. The bottom number, the atomic number, tells you the number of protons. The mass number is 19. To get neutrons, you would have to do 19 minus 9 equals 10. Again in the nucleus. The electrons go round the shells. There are 9 in total, 2 in the first, 7 in the next. Electronic configuration 2.7. To get 5 or 6 marks for this question, it needs to be a detailed description, communicate your ideas clearly, and have proper spelling, punctuation and grammar. There you go.